In this video, which is the final one, I'll work through some examples of calculating probabilities. So let's suppose we have 10 people in a park and 4 of them are wearing sunglasses, 5 of them are wearing a hat, and 3 of them are wearing both sunglasses and a hat. Well, how can this be, you might think? We've got 4 and 5 and 3, which comes to 12. We've only got 10 people. Well, we need to be careful here because 3 of them are wearing sunglasses and a hat. But the 4 people that are wearing sunglasses, some of them might be wearing a hat, some of them might not. And the 5 people that are wearing a hat, some of them might be wearing sunglasses, some of them might not. So we need to think about, of the 4 people that are wearing sunglasses, we're told that 3 of them have both sunglasses and a hat, and so one of those people must be wearing just sunglasses and not a hat. And then the 5 people with a hat, 3 of them also have sunglasses, and so 2 of them must have a hat but no sunglasses. So if we want to answer the question how many wear neither sunglasses nor a hat, we start with the 10 people in the park, and then we're going to subtract people with sunglasses but not a hat. So that's 4 minus the 3 that have both. So I'll just write that down, 4 minus 3. So those are the people with sunglasses but not a hat. How about the people with a hat but no sunglasses? We have 5 with a hat, 3 with both. So 5 minus 3 must be the number of people with a hat but no sunglasses. And then we've got the 3 people that have both. So that accounts for everybody with either sunglasses or a hat or both. And so if we subtract that from 10, we'll get the people with neither sunglasses nor a hat. So that comes to 10 minus 1 and 2 and 3 comes to 6. So we get 4 people who are wearing neither sunglasses nor a hat. All this information can be simpler to understand if we create something called a Venn diagram. And to fill in the Venn diagram, we can fill in the 3 people who have both got sunglasses and a hat on. And then the 4 people with sunglasses are going to be in this orange circle. 3 of them are already in this part of the orange circle that overlaps the green circle, which is the hat folk. So there must be 1 person here. And then the hat people in the green circle, we need 5 people in total. 3 of them are in the overlap, and so there must be 2 in this section. And seeing as we've got 10 people in total, and we've accounted for 6 of them, there must be 4 people outside the 2 circles. And those are the people wearing neither sunglasses nor a hat. Now let's imagine that we are picking 1 person at random from the park, from the 10 people in the park. What is the probability that they're wearing sunglasses but no hat? So we can look at our Venn diagram and we can see that's the part of the orange circle that doesn't overlap the green circle, so it's this 1 person here. So the probability that the person picked at random has sunglasses but no hat is 1 out of 10, or 0.1, or 10%. How about the probability that that person we pick at random has a hat but no sunglasses? So hat but no sunglasses is the 2 people here in the green circle that doesn't overlap the orange circle. So that's 2 out of 10, or 0.2, or 20%. How about the probability that this person has either glasses, sunglasses, or a hat on? So that's the people inside the orange and the green circles all together. So 1 plus 3 plus 2, so that comes to 6 out of 10. Or 60%. And then finally, what is the probability that this person is wearing neither sunglasses nor a hat. So we can calculate that using the answer to the last probability that we calculated, 1 minus 6/10. So that comes to 4/10. Or alternatively, we could just look at the 4 people here outside the 2 circles, and that's 40%. How about instead of picking 1 person, we actually pick 2 people out of the 10 people in the park? And first of all, let's suppose we're picking without replacement, which means we're essentially picking the 2 people at the same time. What is the probability that both people have sunglasses and a hat on? So for the first person that we're picking, the probability that they've got both sunglasses and a hat on, that was the 3 people in the overlap. So 3 out of 10. But then the second person, we've only got 9 people left to pick from, and we've already picked one of the people who have both sunglasses and a hat on, so there's only 2 people left who have both sunglasses and a hat on, so 2 out of 9. So if we multiply that out, we'll get 6 over 90, which is the same as 1 out of 15, which is the same as 0.067 or 6.7%. And then finally, how about if instead of picking the 2 people without replacement, we pick them with replacement, which means we're going to pick the first person, and then we're going to put that person back into the pool of people we can pick from, and then pick again. And so this time, the probability that the first person has sunglasses and a hat on, still 3/10, but now the probability that the second person picked has sunglasses and a hat on is also 3/10, because we put the first person back in the selection pool. So now that probability is 9 out of 100, which equals 0.09 or 9%.